Now we will learn about cylinders and cone. Now surface area of a right circular cylinder. If a number of circular sheets of paper are vertically stacked, we will obtain a right circular cylinder. That means that if we have circles and circles and circles like this, one circle, two, three, four, and similarly we keep on stacking these up, we will end up getting a right circular cylinder. Here right is referred to as the right angle that it makes with the base. Circular means that we have a circular base and cylinder is then formed because of stacking up. Now, in now as you have seen that we have the base at 90 degree. Now, right circular cylinder has this special property, but the cylinders like these, we can say that this is a cylinder, but it is not right circular. It is not right cylinder because it is not making right angle, but instead it is making an angle. It will go with the axis of the cylinder and the base, and it is making the angle theta. Some angle we don't know. So this is not a right. It is not a right cylinder. Now this is not a circular cylinder because even if it is making the angle 90 degree, but the base is not a circular base. It is folded like this and it is making some other shape that we do not know. So these cylinders are not considered in your course in this chapter, and we will not be finding the surface area or volume or anything related to the curved surface area or anything, and we will not be studying about these cylinders, but you should know about that what all possible cases of cylinders are. So now we move on to our activity. So this is your activity in this. You have it is to give you an intuition. It is to help you visualize that how we will find the curved surface area of a cylinder. To do that, we can if we roll. We know that if we roll the cylinder, or when, for example, you might have rolled your book like this. So you after rolling it, you get a cylinder, a hollow cylinder. So we can see that whenever we roll a rectangle, we get a cylinder. So if our length, if we'll consider this to be our length and this to be our breadth. Okay, so when we roll this up, the breadth will actually become the height of the cylinder, right? So we can say breadth is equals to height, and the length, you can see that length is the perimeter of the circular base of cylinder. And if we consider that this it have a radius r, then we can say that our length is equals to 2 pi r. So now, if our length is equal to 2 pi r, our breadth is equals to h, we know that the area that we have in here will give us the area of this part. So we can say that the curved surface area, which we can write as CSA, is given as length into breadth, which is equal to 2 pi r into breadth, which is height. So we have 2 pi r h. So this is our surface area, the curved surface area of a right circular cylinder. That is length into breadth of the rectangle, which is equal to 2 pi r, where r is the radius of the cylinder and height is given by the breadth of the rectangle. So we have hence found the curved surface area of the cylinder. That is the surface area. It can be said as the literal surface area because we're not including the top or the bottom, only the curved part. Now moving on to find the total surface area. Total surface area, that means the top and bottom also. Since the top is made up of a circle and the bottom is also made up of the circle, and both the circles are of equal radius, so and they are the same. So we can say that the total area would be curved surface area plus the areas of these two cylinders, these two circles. So we'll add CSA plus area of the top and bottom circle, We know the area of circles is given as pi r square plus pi r square, where r is our radius, right? It is our radius of the cylinder. So it can be given as this, and we know CSA is 2 pi r h. Now 2 pi r h plus 2 pi r square. Since these were like term, I've added it. We can take out 2 pi r common. 2 pi r is common, so we have h plus r. And this gives us the total surface area of the cylinder, where h is the height, that is this part, making 90 degree with the base, and our radius is given by r. Now let us do an example with this. Now I'll just read out the question that Savitri has to make a model of a cylinder kaleidoscope for her science project. Now kaleidoscope is an optical instrument. It is a cylinder which has a lot of reflecting surfaces, and you can see various beautiful patterns in here. You might have had this activity in your smaller classes, I guess fifth or sixth, but just to brief you up, it is an optical instrument which is cylinder and has deflecting surface, and whenever you draw a pattern over here, you see a very beautiful pattern that is reflected, very symmetrical in shape. So it is basically, you can consider it as a cylinder in this. For us in maths, it is just a cylinder and nothing more of a visionary thing. So now she want to make a cylindrical kaleidoscope for a science project. Now she wanted to use a chart paper. She wanted to use a chart paper to make a curved surface area of the kaleidoscope. Okay, so she wants to make it with a chart paper, and how can she make it? By rolling it, right? So what would be the area of the chart paper required by her if she want to make the kaleidoscope of length 25 centimeter and radius is 3.5 centimeter, and pi is given to us this. So now she want to make a kaleidoscope, and now we have a cylinder, right? With a chart paper, and the radius is given as 3.5 centimeter, and the height, height would be our length, right? Because this is the length and this is also the height, so we take the height as 25 centimeter. Now we have to make it, now we have to find this curved surface area, right? Because she wants to make a kaleidoscope, and she can do it by only rolling the paper. So if we open this up, we'll get our height to be 25 and our breadth to be 2 pi r, which is this. So that is how she has made the kaleidoscope. So now using this simple formula, we can directly do length into breadth, or we can use the CSA of a cylinder, which is 2 pi r h, which is automatically length into breadth. So now when we do that, 2 into pi is given to us 22 by 7, our RH 3.5, and then we have 25. I'll just write it over here so that you can see it clearly. So ICSA is given to us as 2 into 22 by 7 into 3.5 into 25. Now 7 can cut 3.5, and we'll get 0.5. And now we can see that 0.5 in this can cut, and 22 into 25 would give us 550 centimeters square. So this is the amount of area that she needs of the chart paper to make a kaleidoscope of given dimensions. Now let us move on to our next one. Now we have an activity over here to help you visualize what right circular cone means. Now here we can see that right is for angle, circular is for circle, right? So the base is circle. So we'll come to this part later, but let's first do the activity. Now in this activity, we have to cut out a right angle triangle. We have to cut out a right angle triangle. So we have cut it, a right angle triangle. And what you have to do is first you have to rotate it like this so that you have a the point is over here and 90 degrees around you, and then just put a stick over here, paste a stick over here so that it remains straight. And now when you rotate this thing, now like this, when you rotate it, you'll see that when you rotate it in speed, you'll see that a shape is being formed like this, right? So you're rotating it and you'll see that this part will make a circle, right? When you rotate this thing, it will make a circle like this. And the triangle sides will make a like shape, and you'll figure this out that it looks similar to the ice cream base that we get, right? It will give us a shape like this, and it looks like a ice cream base, right? So this is our ice cream and this is our cone, and we call it, even in ice cream we call it a cone of the ice cream, right? So you say that you want to buy a cone ice cream or a stick wali ice cream, right? So we're just using this analogy to help you get to the concept of cone. And since it is a right angle triangle, we know that this would be our height, and this thing, and it will make 90-degree with the base. So that's why we have called it a right angle triangle. And since rotating it is giving us a circle as a base, so we call it circular, right circular cone. So this was our activity to help you figure out how a cone is made. It is like stacking the right angle triangle like this. We're stacking it like this. When we rotate it, we get a right angle triangle, a cone, right circular cone. Now that was those were right circular cones. Now similar to the cylinder part, we can see that these cones, these are also cones, but these cannot be considered as a right circular cone. These are not right circular cone because first of all in this we do not have right angle. A right angle is here, but this its height is making some angle theta with the point, and we call this point as our vertex. In the previous slide also, the point A about which it is rotated, this point is called as vertex. The point about which it is rotating, the tip of the cone, this point, the tip of the cone is called our vertex. So now, here also, the line joining its vertex to the center of the base is not at right angle to the base. So we can say that even if this is our height, this the line that is joining the center to the vertex is at angle theta. Okay, so we cannot consider it as a right circular cone. While in this, even if our height is the same as the vertex, right? That is, our vertex is also the line joining the vertex and the center is at 90-degree with the base, but still the base is not circular. So this is not a right circular cone. Now let us find out the surface area of a right circular cone. Now this is also an activity because we cannot directly derive it. It is a complex process which you may do when you opt for higher studies in mathematics. But right now we'll do it with activity. So now what we have to do is we take a cone that is empty, that do not have bottom. We'll remove the bottom, and then we cut it from we'll cut one of the we'll cut it from the outer surface. So we cut it from here like this, or from here, any part of the outer surface we'll cut one part. The outer this line that is joining the vertex and the boundary of the base, right? This boundary, not the center, the boundary of the base is called as our slant height. Slant height. It's SLANT, slant height. So this is called as slant height. So we'll cut the right circular cone with its slant height, mark the points A and B. And when we open up, let us figure out what the shape will look like. It will look like something of a piece of a cake, as if this is a cake and we have cut a piece out. So now, to figure out the surface area, what we'll do that we already know that this area would give us this surface area, right? So what we'll do that since we do not know it is not a well-defined geometrical shape like a circle or a rectangle that we were using previously to find the surface area and of the various shapes. But what we can do here that we will cut the portions like this. We'll keep on cutting the portions of the circle of the shape that we have got, and we can see that it is approximately forming a triangle. It is forming a triangle. We can cut it as small as we want, and it is forming a right angle triangle because you must be knowing what tangent is. So whenever we draw a tangent to this part, the radius always makes 90 degree. The radius always makes 90 degree with the base. So hence the radius is always making 90 degree at the points of the circle, at the perimeter of the circle, at the boundary of the circle. So we are always getting a 90 degree over here, and hence we are getting a lot of 90 degree that is right angle triangles. So if we'll sum over all the right angle triangle, then we can get the surface area of this shape. So let us do it is just take these three parts so that you can just get an idea. It's not compulsory on how broad you cut the things. We just have to cut it as small as you can, or it's totally optional. So we'll cut it like this. Now our base is this is our base, and this is our B1. This base is our B2, and if we'll cut one more over here, this is our B3, right? So we have cut, for example, we have cut B3, and this length is our slant height, right? Because we have cut it from here, we can see that this is our slant height. A to the vertex is the slant height, L, and A to the vertex, O is our vertex. A to the vertex is the slant height. So this will be all this land. These all are will be the slant heights. So we have L. So now one of our shape that is the base will be our L, our slant height. So now let us calculate the area. First, let me draw all other triangles. This the one with the B2, B2L, then another with B3, B1. L. So similarly, we can get a lot of B100, B infinity. Till infinity we can go. So now it depends on how small you cut the triangles. So now let us sum over these. So the area of one triangle, this area is given as half into base into height. Here our half base is L and our height is B3, right? We can take this as our height. So now let me sum over 2. We have LB3 plus we have half. When we'll do this, we'll find the area of this triangle. We know LB2. So we'll add LB2 plus half LB3 and so on. We'll keep on adding. So now when we'll add, let me take common L half. Half into L can be taken as common. So we have B3 plus B2 plus B1. This is our B1 actually. B1 plus we can go on and it will go on increasing. We have B4, we have B5, we'll cut it. Then we have our this is our B4, B5, and similarly we can take it over a lot of numbers. And let us consider that our last number would be our Bn. N is any number, can be 100, can be 1000. So we'll add on to Bn. Now you can see that this half into L, and there's a lot of numbers over here. So but when you sum these over, so B1 plus B2 plus B3 plus B4 plus B5 plus B6, 7, 8, and similarly 9, 10 to B10, Bn, you can see that we are getting the perimeter.